Welcome to ClickMyProject.com. Our title is Efficient Keyword Searching in Large-Scale Social Network Service. Let's discuss about our abstract, in which different from a traditional web searching, the relevant information for a social network system SNS is commonly the content from his or her friends, such as difference makes content indexing extremely difficult for an online social network OSN search system, because every user has an individual view during a searching. Building such a using user view index over existing SNS key value stores rising for large amount of communication cost due to the complex interconnections among OSN users, making these such systems unscalable. To address this problem, we propose a novel protocol called summary index to support a keyword searching. In this protocol, each user keeps a directory of the sufficient summaries of his or her neighbors, and checks these summaries for potential hits before sending any queries. Two factors contribute to the low overhead of our design. The summary index representations are memory efficient, and the summary dissemination for index updating is communication efficient. First, we design an incremental scalable Bloom filter for summarizing the content constantly generated by a neighbor of a user. For an issued query by a user, the search system first checks against the summary index for users' neighbors to predict the neighbor likely having desired contents. Thus, uh, thus the search system saves significant inter-server communicate cost by avoiding exhaustively transmitting the query to all the neighbors. Second, to further reduce the overhead for maintaining the social index, we will leverage the back strategy, which exploits the links with high social strengths to avoid redundant messages during the updating the per user view summary index. We conduct comprehensive simulations using traces from a real world system to evaluate its design. Results shows that our scheme significantly outperforms 60 schemes for OSN searching in terms of inter-server traffic by 98%. This flow is represents a content provider, content generation, and apply aggregation, in which the aggregation are centered to the content's intelligence. Then the contents received from these upper parts and will provided to the lower parts content processing and synthesization, given to social user crowd patterns and propagation. Then finally, all the details are sent to the user intelligence. User intelligence will evaluate the results. Efficient keyword searching in large-scale social network service. This is our home frame, in which by clicking this button, we will produce a current date and a current date. And then this frame will be the user registration, in which user need to give his user ID and username. By clicking enter, the details are provided by the users are saved into the database. The panel will shows that successfully entered into the particular or proposed. This one is a user authentication frame, in which by clicking this you will get a current date and current time. Here we need to give user ID, user password. Here the key should be generate first, so we need to click a generate key button to generate a random key, and by clicking authenticate, then in this frame user will upload a file. These are a file already existing in our database. Here, if user want to upload a technology file, by clicking in details and view contents, by clicking upload, then after that user will need to provide his private key in this frame. To upload a file, user need to give his private key. Here key was verified, and here we need to enter our queries. By clicking verify, content will provide. These are the files that are related to the science. This may be political science, animals related. In which by clicking away files, all the files will be shown. No data. By clicking the next frame, there is a crowd pattern based replication, in which we have to replicate by clicking this. Then the replicated data files are generated. Clicking this crowd ranking based data, in which there is a content will be related as science files. We have to store it, and which here this is a final frame, user intelligent frame, in which the list of files will be shown. Selected files will be shown in this frame. By giving a ranking, and after that we will download our file. The downloaded file will be stored in our local folders. Then finally we get a graph like this. Thank you.